Okay, let's dive right in with a pretty huge question. Can AI, and I mean really, measure something as complicated and, as human as happiness?
So let me ask you something. Just think about it for a second. Is your country happy? I mean, as a whole. It sounds like a simple question, right? But the answer, well, that's where things get complicated.
And that's the real kicker, isn't it? How would we even know? Seriously, how do you take the emotional temperature of an entire nation, millions of people, all at the same time? That's the puzzle we're going to try and piece together today.
You see, for a long time, the way we've tried to figure this out, it's relied on some pretty old-school methods, kind of like trying to measure a digital file with a wooden ruler.
So the old way, that's all about traditional surveys. And they're slow, they're expensive, and they're always looking backwards. But the new way, it's using what's called natural language processing, NLP, to see what people are actually saying online, right now, in real time. It's really the difference between looking at a single old photograph versus watching a live stream of a country's mood.
And this is where it gets really cool. This is the modern solution. We can actually use AI to listen in on a nation's collective voice. It can analyze everything, social media posts, news comments, you name it, to get this incredible dynamic pulse of how people are feeling. The key idea here, the big concept, is something called experienced utility. Sounds fancy, but it's simple. Instead of asking you, hey, how happy were you last week, which is all about memory, this method looks at the words you're using right now to capture your in-the-moment feelings. It's a huge shift from recalled satisfaction to real-time experience.
And the potential for this is just massive. Think about it. Governments could see the immediate impact of a new policy. Companies could actually measure what's being called corporate happiness responsibility, like how their decisions affect the public mood. It takes this fuzzy idea of well-being and turns it into something you can actually track and act on.
Okay, so this all sounds great in theory, but what happens when you try to use this super powerful tech on one of the most complex languages on the planet? Yeah, this is where our story takes a really fascinating twist.
So, to get what's going on, we need to talk about something called morphologically rich languages. Basically, these are languages where one single word can be crammed with the meaning of an entire phrase. Hebrew is a perfect example. For an AI trying to figure this out is like going from level 1 straight to the final boss. It's a huge jump in difficulty.
All right, take a look at this single Hebrew word. To a normal AI, that just looks like one thing, one piece of information, one token. But it's not. It's actually a really complex puzzle, hiding in plain sight.
And here's the big reveal. That one word, it actually breaks down into 5 different English words. And, when, from, the lab. An AI has to be smart enough to pull that all apart just to understand the basic sentence. Your standard translation app? No way. It would completely miss this.
And just when you thought it couldn't get any harder, there's another layer of complexity. You see, written Hebrew often leaves out the vowels. This creates a ton of ambiguity. So this word right here, without any context, it could mean orbit, or the coffee, or even her perimeter. The AI can't just look at the word in isolation. It has to understand the entire sentence around it to have any clue what's being said. So, okay, the challenge is huge, right? So how in the world do you build an AI engine that can actually crack this incredibly tough code and, get back to our original goal, measuring happiness?
Well, it all starts with a classic question that anyone in tech will recognize. It's the build versus buy dilemma. Do you build your own custom tool from scratch, or do you just buy something that's already made?
The team here had a big choice to make. They could buy, use a general-purpose tool like GPT-4o. It's powerful, for sure, but it's not a specialist. Or they could build, using models like Hebert that were trained from the ground up specifically on Hebrew. And when you need this level of precision for a language this complex, building your own was really the only way to go.
So the process is pretty intense. You're gathering and cleaning just massive amounts of text data. But honestly, the most critical step, the one that makes or breaks the whole thing, is the last one, finding and getting rid of bots and fake accounts. Because if you don't, your entire happiness score could be totally manipulated, and it would be worthless. You've got to be sure you're measuring what real people are saying.
Okay, but let's pause for a second. Having this kind of power, the power to listen in on a whole country, that comes with a huge amount of responsibility. This isn't just about code and algorithms anymore. It's about walking a very fine ethical tightrope. First up, you've got privacy. Public online text is just full of personally identifiable information. But you can't just delete it all because that would wreck the context of the data.
So the clever solution is something called synthetic data replacement. You basically swap out real names and details for realistic but fake ones. That way you protect people's privacy, but you keep the data useful enough for the AI to learn from.
And then there's the fairness dilemma. It's the old saying, garbage in, garbage out. An AI is only as good or as unbiased as the data you feed it. So if the data it's learning from already has society's biases baked in, political, religious, whatever, the model won't just learn them, it can actually make them worse. And that could lead to totally skewed results and really bad policy decisions.
But here's the thing. Fixing bias is not easy. At all. In fact, a recent study found something pretty shocking. In over half the cases, 53%, the tools used to try and make an AI more fair also made it less accurate. That's a huge trade-off that the people building these systems have to wrestle with every single day. So how do you navigate this minefield? You need a really solid ethical framework. It comes down to three big things. Transparency, so we all know how it works. Human oversight, so there are always real people checking the AI's homework. And clear governance, basically strong rules to prevent it from being misused. Without these, you'll never have public trust.
So, okay. We've gone through the incredible technical challenges and the serious ethical questions. Where does that leave us? What does the future actually look like now that we have this kind of tool?
When it comes down to it, this technology is really a new tool that could help build a better world. Having a reliable, live pulse on how people are really doing, that can empower leaders to make smarter, more human-focused decisions, the kind of decisions that genuinely make people's lives better.
And that brings us to one last really big question to leave you with. It's a question that sits right on the border between technology and what it means to be human. If we can finally and accurately measure happiness, does that mean that one day we'll be able to engineer it?